minutes when people are gone. So here we go. The first thing that you're going to do is label all of the elements that are diatomic. So I'll do it in red. It doesn't matter. You're just going to do this in pencil. So right up here, write the word and write it smaller than I'm going to write, but put diatomic. Oh, that is super ugly. Hold on. Okay? Put the word diatomic, and then right after that word, you're going to put a 2. And it'll hopefully make sense in a minute what I mean by that. All right. Everything we do today, check that your lab partner did the same thing. So we are solid. You don't want to screw this up, because if you do things wrong, then you have the wrong answer. All right. So a diatomic means 2. There are some elements in this world that when they are found alone, they are not found alone. They're found hanging out with another one of themselves. That's what we mean by diatomic. It means 2 elements stuck together, or if it's diatomic, it means 2 of the same atoms. So when H is found alone, it's found with another H. These atoms right here are your diatomic. And put the 2 smaller. It's just hard for me to put a small 2. All of those atoms, when they are found in nature, are considered diatomic. All right, check your lab partner fast. Now, the reason this will be important is for now, it's just a simple question. It will say, like, is element 17? So you would look over there, element 17 happens to be chlorine. And this would be a test question. It would say, is element 17 diatomic? And then you just say, yes. It's a super easy type of test question. We're giving you the tool, and then we're going to assess whether you know how to use it. All right, so that's the first thing, are our diatomic atoms. Easy enough. Okay, the next thing we're going to do is toxic. So, I don't know, toxic. And toxic, you're just going to put a little T in the box. You okay with that? All right. Now, the location around the symbol, from now on, it doesn't really matter. I like the 2's right next to them on the bottom right, but the rest, it doesn't matter. All right, and most likely, just right this second, I won't remember which ones are all toxic, but we'll get most of them. All right, so the ones that are toxic, first off is nickel. Nickel can be toxic to some people. All right. Arsenic is toxic. We good so far? All right. Fluorine, bromine are toxic to people. Phosphorus is toxic. And then there's one down here. I guess I can scroll. All right. Most of these are most definitely toxic and radioactive and nasty, but the one specifically we want is Pu, which is aptly named because it's green, it's toxic, it's super radioactive, and it will light you up. Okay, I know for sure, I always screw this up. There are probably a couple more that are toxic that we'll point out over time when I remember off the top of my head. All right, I should have looked that up, but I always forget. All right. So far, so good. Check your lab partner real fast. All right. The next thing you're going to do, can you see this like weird looking line right there? Yeah, thank you. It is kind of weird looking. We're going to call that the staircase, and we're going to color that nice and black or dark or something, and it's going to separate our metals and our non-metals. So make this a real nice, dark, heavy staircase line. what did I mumble that was separating? All right, metals and non-metals. You don't need to write this really big and fat like I will, but everything on this side is pretty much a metal. And then everything on this side is pretty much a non-metal. And don't write it huge like I am. I'm just doing it for emphasis. But write it somewhere. All right? The bar or staircase or whatever we want to call it will separate the periodic table into two halves. Now they're not equal halves. They're super not equal halves. But we're going to say it. Those are mainly the two types of metals and non-metals. I got you. All right. Good so far? Pretty simple. All right, the next thing that we're going to do, this time you're going to use a colored pencil and you're going to highlight some boxes. And the boxes you are going to highlight are called metalloids. So choose whatever color you want. So I'm going to use my highlighter tool here. Maybe. I'm trying to use my highlighter tool. Maybe I won't. How come it won't let me do that? Oh, it's that one right there. All right, we'll just go yellow because it's there. And then up in my key, I'm going to make a little yellow box or whatever color you chose. And that color means it's going to represent a metalloid. Because the periodic table it consists of metals, non-metals, and then a couple of weird things. And we're going to call those metalloids. And you're going to shade those in. And they are right here. Nope, that's supposed to be a highlighter. Hold on. All right, so boron, silicon, germanium, arsenic, antimony, tellurium, and we'll call that good right there. So those are what we consider metalloids in this class. What?
I asked him what TE was, and he told me that he had.
Well, that's not one you have to memorize. It's tellurium. It's not really one that's ever talked about, used, or anything like that.
Yeah, Davis, why do we have all these blank spots?
Well, you have all those blank spots because they're just UUUs, essentially. So you got UUB, UUT, UUQ. But when we made this, those past B haven't really been discovered. And look, the UUs, every year they get, well, about every 3 years, they get one more that they finally isolated and got that it will at least last like a microsecond. But their name, UUB, just means un, and then the B means two, like bicycle. The UUT means UU tri, UU quo, UU penta, UU, and it just goes off of like geometry things. So we're not really going to worry about them, but that's what they are. All right, check your lab partner and make sure they have the metalloids colored in. Make sure that they have that in their key as well. We good? I'll move on if you give me a thumbs up. All right. The next thing we're going to do, it's a lot like metalloids. Let's see here. Let me see if I can shrink this down. So the next one, pick a color, make something like metalloid, and name it gases. So some of these things, when they're found in nature, they're found as a gas. Everything else will be a solid. This will be the biggest one you color, so pick your favorite color for this one. Okay. Whatever, that says gas. All right, so what we're defining here is if we just found the thing in nature, what state of matter would it be in? And these are the ones that are gases when you find them in nature. It's almost all of them that we put a 2 by, but you got your hydrogen, and then it's nitrogen, oxygen, fluorine, chlorine, bromine. This is getting ugly over here. But whatever, we'll live. And then it's all of these noble gases. That's really ugly how it changes the word metal to black. Yeah, it is. I'll just get that out of the way. All right. I'm not super OCD. I apologize if some of you are. We're going to call this pretty much, oh crap, bromine is not. I don't know why on earth I did that. It's okay, it's okay. You'll color it a different color. And if you colored it already, it's not like a disaster, because then you can just call whatever that color was what bromine is. Hello, Randy.
Hello, sir.
Randall, hello, Administrator Rasmussen. What kind of amateur would color bromine gas, Randy? Is that what you were wondering?
I would not have.
Put that in my evaluation.
We'll have to discuss that when we meet.
Okay. What's that? T. Thank you. All right. We good? Sorry about the bromine disaster of 2017. Oh, man, you got very good at coloring in between the lines. Let's see. Look at me. I need to slow down.
Because it's how the colors in the lines. I don't care. I just go like this, as long as it's the color. That's all I need to know. This, and this, that's why I did it.
Oh, man. All right, check your labby, make sure they have the gases. And then the next one we're going to add are the ones that at room temperature is found as liquids. Are you as bored as you look? I apologize. Don't ever look like that again. That made me cry inside. All right, so now, liquids. There's only 2 of them, and bromine is one of them. So if you colored bromine before, just color over it, and then do the same thing. The only other liquid naturally found is mercury. Hg. What?
Particle. Gray mist.
All right, how are we feeling so far? Check your lab. You got both those. And make sure they label that those are the liquids. All right, so I get this all the time. If we did not color it, then at room temperature it is a
Gas.
a solid. All right, if we didn't color it, one of those liquids or gases, then if it asks you on your exam, you're going to say solid. Now, look, we did color the metalloids. Does that mean they're not a solid? No. We know they're not a gas and they're not a liquid, so the only other option on the periodic table for us is that they are solid at room temperature. Easy enough? Okay, so once again, how this will work, and there's plenty more, so just don't write anything yet, but I will say something like, the following questions refer to element number 9. Okay? This is exactly how you will get it on your test. Now on your test, it will have this right by there, but element number 9 is fluorine. And on the test, it doesn't have both numbers. It only has the one, so it's almost foolproof. All right? And then it will say something like the following. Is element number 9 toxic? Tell your labby.
Yes.
All right. Is it diatomic or monatomic?
Diatomic.
Diatomic. What do you think monatomic means then?
One.
It means it's one of these that's not a 2, right? All right. It will say, is it a solid, liquid, or gas at room temperature?
Gas.
It's a gas. And then it could also say a few other things we haven't done yet.
Can we use this?
You will use that. So it's not hard at all, right? It's just, can you use this tool that I'm giving you? Let me get rid of the all use. All right. The next little bit, oh, never mind, we're not there yet. What we're going to do now is we're on the top. We're going to put some Roman numerals to describe the families. The periodic table is like a grid system. It's like a map. It has north, south, east, and west. But we have families or group numbers and periods. And we can use that language to identify where we are. So we are going to put Roman numerals. We'll just do lines so they're straight. Family number Roman numeral 1. Actually, I don't want to do lines. Let's just do it like a marker. So above this first column, put an I. That's a Roman numeral 1. No, you won't. You won't do it here. Yeah, that's fine. It's fine. Even here, it won't matter. All right, ready? We're smart, so we're going to say this is probably family what? 2. I knew you could do that. That 2 looks confusing, but you know what we're doing. Okay, then we skip all of these. All right, we skip. These are called the transition metals. We might as well write that right now, by the way. Put a little parentheses right there and put transition metal. All right. As far as families are concerned, we don't number the transition metals. We just say that entire huge, massive family is called the transition metal. All right, so we jump over those. Well, I'll wait. Look at the screen when you're ready to go. Check your lab partner got transition metals. On the next test, one of the most common ones, it's like 80-something-ish. It says, what's the name of the family? And it's one of these, something like that. And you put, there's an option for answer is not there to cover my butt on a bubble sheet. That's not the answer. The answer, the name of this family is the transition metals. All right? So hopefully we got that. All right, then we're going to jump over. And this is family 3. That is 3 I's, essentially. The next one is family 4. That's an I and a V. The next is family 5. This is getting hard, so I'm going to skinny up my marker. I tried. Everyone look. Evidence I'm trying, but it won't let me.
Try going thicker, Davidson.
I don't want to. I want to go skinnier. Getting thicker is a lot easier than getting skinnier. Right, Randy?
Oh, yeah.
I'm not making fun of Randy. I'm making fun of getting old. All right. Then we have VI. That's 6. VII. That's 7. And then V and 3 I's. That's family 8. All right. Now, wait a second. Check that they have those. Good job. I tried. We won't do it, Allie. All right. What you're going to do now in this key area, you're going to write family/groups because they mean the same thing. Family/group. And then you're going to write equals Roman numerals. Okay? Because if you find a Roman numeral, that's your family or group. I'm not going to try to spell numerals. M-O. Yeah. There you go. At least you know how to pronounce it. Most people are like, what's the Molly did you? All right. So if you see the Roman numeral, that's describing your family or your group, right? Okay. The other thing, we label the rows, and they're called periods, and they just go down the left side. They're easy. 1, 2, 3, 4, 5, 6, 7. And if there's room, horizontally, or vertically, I guess, write the word periods by those. This thing's getting awfully crowded, huh? It's good though. Like the more we put on it, the more useful it will be. Okay, so coming back, we could now ask another question about fluorine. We could say, remember we were talking about element 9. We could say what family is it in, and you would say family 7. All right? And then we might say what period is it in, and it's the second one down. So you would have those two. We're talking just about that one.
That'd be 2 eyes. Yeah.
What I put? Oh, I did put 3. You're right. It is 2. I said 7, wrote 3. That was just a really fat one. Sorry about that. All right, but good. Thanks for correcting me. All right, so you see how we're like layering the onion from the inside out instead of unwrapping it. We're just making things complicated. That's my job. I get to take things you thought you always knew and make you realize you never knew anything about what you thought you knew. It's pretty fun. All right, the next thing that we're going to do, we're going to draw lines that indicate trends. And you're going to do this with some colored pencil. It doesn't matter if it's the same color, but it can be a different color. So the first one we're going to draw is a line that is showing you the trend for density on the periodic table. So now you wouldn't erase anything, but I'm going to erase some of this stuff just to give me some room here. All right, so what you're going to do now, pick whatever color line you want. What color do I want?
Brown.
I heard purple and I was above purple, but who knows, it might not even work. We're going to go red. All right, so what you're going to do is you're going to have now an arrow in that color, and you're going to write density. Okay, so the arrow in this color is describing the trend for density. Okay, so here we go. The trend for density is very simple, and you can put it anywhere over here. It doesn't matter exactly where you put it, but the trend for density, as you go lower on the periodic table, density increases. Okay? So the arrow will always be pointing to the higher place. Good with that arrow. This is where I usually lose kids, but I think doing it on this board is actually a lot more helpful. All right, then that's the up and down as far as side to side. And once again, I don't care where you put this, but density will increase as you move towards the middle. And it doesn't matter where you end. Like I ended with iron. It doesn't really matter. It just matters that the lower and more middle you go, the higher the density. Okay? So you need the one lower and the one pointing to the middle. We're close. And then we're going to do a ton of homework. That sounds like a nightmare, but it's so not hard. Let's see a lot of angry colors. Just here, the pencil's about free. All right. So now, density is a little bit trickier. Remember family or element 9 we were talking about? Now we would say something like, is element 9, so we're still fluorine, more or less dense than element I? It's less because it's higher. And the arrow says the lower I go, the more dense I get. Easy enough? Okay? And we'll do a lot of these to practice. Don't stress if you're there. All right, the next arrow, it's one more arrow and then we're done pretty much with that part, is melting point. Green won't be a good idea. Blue, right, blue will work. Blue should be fine. All right, so this arrow you're going to label melting point. All right, this one's pretty annoying because depending on which side of the periodic table you are, it's different. So make sure that you're careful with this one. So melting point is the blue line. In metals, melting point increases as you go up. Put that one. All right, then this is why it's not very fun. In non-metals, the melting point increases as you go down. All right. Now, the side to side is the same. For melting, it still increases as we go towards the middle. All right. Check that they have the melting point now. We good? Well, wait, let me,
She's picking on me, Davidson. Oh, thanks for my colored pencil back. It's so funny. Oh, wow, you said I was picking on you.
just looked, and there's just one thing that I forgot to do earlier. It's not a big deal at all. When we do the numbers, I was supposed to have you do something here at the bottom. All right, there are 4 families that have names. And we're going to name those. So you're going to write like right here. And you can, the style that you write, I don't really care. But this first family up here, oh boy, that's not good. What happened? Okay, that's hideous. Right there. Those are called the alkali metals. A-L-K-A-L-I metals. So once in a while, the test will say, what family number does it belong to? And you would say alkali metal, or sorry, you'd say family 1. Sometimes it says what is the name of the family, and you're supposed to write that name at the bottom. Rose, did you get what you needed? Did I lose you? Okay. Now, this will be hard for me to write. Family 2 is called the alkaline earth metals. A-L-K-A-L-I-N-E, earth, I'm just going to put E-M, earth metals. So most of your disposable batteries are called alkaline batteries, and that's because they're made out of metals from family 2. Alkaline earth metals. Okay, family 7. So we skip all the way over here now. Family 7 is called the halogens. H-A-L-O-G-E-N-S. Halogens or halogens. Have you heard that word before?
Yes.
Where?
Jimmy Neutron.
Okay, besides Jimmy Neutron.
Sorry.
It's all right.
Test tubes for the heated iron sulfur.
Should be a huge white box. We just opened a new one.
Okay. Now that I know what I'm looking for.
Okay. All right. Most people, if they say yes, they've heard of a halogen light bulb. Anyone? Any? Okay. Well, that's because LED bulbs are nice now. But when they went from the incandescent bulbs, which you don't probably even know what those are anymore, but a normal light bulb, the first version of the long-lasting light bulb is called a halogen bulb. But they're actually not cool anymore either because we use LEDs. These are called your noble gases. N-O-B, someone help me, E-L-L-E, gases. There are some words in my life that I don't know, like angles and angels, never going to work. Don't even try and teach me a trick. I don't know. Whatever. All right. Woo. That is it. There's probably, like I said, a couple of things that I forgot, but it's something, but we'll fix it before it's a problem. So are you ready to apply and use our new tool? Take out your lab books. Don't complain. I'm going to do as much homework for you in the next 15 minutes as possible. Who loves when a teacher does your homework for you? Me too.
This is the tree.
Okay, so it's just the back. It's number 57 through 62. I believe is probably just like this. I don't know why my cursor is freaking out, but whatever. All right, so here we go. You're going to use your periodic table to answer these series, and this is exactly how it'll be on the test. I give you an element number, and I ask you a bunch of questions. When you try 57 through 62 yourselves, for the next couple of minutes, and then we'll go over them together.